triangle ABC is inscribed in circle omega with AB equals 5, BC equals 7, and CA equals 3. The bisector of angle A meets side BC at D and circle omega at a second point E. Let gamma be the circle with diameter DE. Then circles omega and gamma meet at E and at a second point F. Then AF squared equals M over N, where M and N are relatively prime positive integers. What is M plus N? We have our triangle ABC, which has side lengths AB equals 5, BC equals 7, and CA equals 3. It's inscribed in circle omega. Then we have the bisector of angle A, which meets side BC at point D and circle omega at a second point E. There we go. We are now going to construct the circle gamma with diameter DE. Given that these circles intersect at E and then at a second point F over here, we want to find the value of AF squared. So the length of this segment squared is equal to M over N, where M and N are relatively prime positive integers. To solve this problem, we are going to employ a strategy from EGMO known as root BC inversion, also known as a force overlaid inversion, which consists of an inversion centered at A with radius the square root of AB times AC, followed by a reflection over the angle bisector of angle A. So first, we know that this inversion swaps B and C, so B is equal to the image of C, which we denote by C prime, and C is equal to B prime. The root BC inversion also swaps the pairs of points D and E. So we know D equals E prime and E equals D prime, where the circumcircle is sent to line BC. And now we can use 2 points to characterize F, because that's the point. We want to know what is its distance from A. So we can use 2 points to characterize F. Point number 1 is that F lies on circumcircle of triangle ABC. And point number 2 is that it also lies on the circumcircle with diameter DE, which means that angle DFE is equal to pi over 2. So we can write point number 2, angle DFE is equal to pi over 2. So now we can use these 2 points to uniquely characterize the image of F under this inversion. So the first one, since F lies on the circumcircle of ABC, we have that F prime would lie on BC. And now since the root BC inversion preserves angles, we would have angle D prime F prime E prime is also equal to pi over 2. But D prime is E and E prime is D. So we just have angle E F prime D equals pi over 2, and F prime is a point on BC. That is enough to uniquely determine the location of point F prime, because we know that F prime lies on line BC, and it's a point such that angle E F prime D is equal to pi over 2. So line segment E F prime is, you could say that it's perpendicular to BC, because F prime and D lie on line BC. So F prime is just the foot of the perpendicular from E to line BC. Let's draw that. We have F prime here. And since E is the point where the angle bisector of angle A meets the circumcircle of ABC, it's just the midpoint of arc BC. And so that's enough to force F prime is the midpoint of BC. So now that we know F prime is the midpoint of BC, we know we can find out the value of AF prime. And then, since we did root BC inversion, which has radius the square root of AB times AC, we'll be able to find the value of AF by doing AB times AC over AF prime. So let's draw an AF prime. And F prime is nothing but the midpoint of BC. I'll just call it M. We don't need F prime anymore, because we know that it's the midpoint of BC, so I'll just call it M. And we can find AM using Stewart's theorem. BM is 7 over 2, and CM is 7 over 2. Now we can use Stewart's theorem to find AM. We know that 7 over 2 times 7 over 2 times 7 plus AM, let's call that little m. Little m times 7 times m equals 3 times 7 over 2 times 3, which is 9 times 7 over 2, or 63 over 2, plus 5 times 7 over 2 times 5, which is 25 times 7 over 2, or 175 over 2. And this is equal to 238 over 2, which is 119. So we have 7 over 2 squared is 49 over 4 times 7. And that's equal to 343 over 4 plus 7m squared equals 119, which is, you can think of that as 476 over 4. So 7m squared is 133 over 4. And so we have m squared equals 19 over 4. M equals root 19 over 2. And now, given that we know little m, we can use that to determine the value of AF. And we know that because AF, it's the square of the radius of inversion, which is AB times AC, over the distance to the inverted point, which is AM. And so AB times AC is 15. AM is little m, which is the square root of 19 over 2. And so AF squared, which is what we want to find, is 15 squared over 19 over 4, which is little m squared. And that's equal to 15 squared times 4 over 19, which is 225 times 4 over 19. And that's equal to 900 over 19, which can be written as m over n, where m and n are relatively prime positive integers. In this case, m is 900 and n is 19. So what is m plus n? It's just 900 plus 19, and that's equal to 919. Thank you for watching my YouTube video, and please follow my channel.